Hello, welcome to Data Streaming Now. I'm Ali Alemi, Principal Data Streaming Architect at AWS, and as you can see, I'm absolutely pumped to be here, coming at you from Amazon's office in Northern Virginia.
And I'm Mindy Ferguson, a VP of Technology here at AWS. I'm sitting in sunny Santa Monica, California. Now, before we dive in, we want to give a huge shout out to our amazing virtual audience joining us from all of the corners of the globe today. So, whether you're starting your Tuesday morning with coffee, whether you're wrapping up your workday, or maybe even tuning in during your late night coding session, we're incredibly glad you're here.
That's right. I want to give a huge shout out to everyone joining us live right now. Whether you're watching on YouTube, Twitch, or LinkedIn, we are streaming simultaneously across all three platforms in real time. The beauty of streaming, well, both data streaming and live streaming, is that it connects us in real time, no matter where you are. So please drop a comment right now and let us know where in the world are you connecting from and what time is it there.
Yeah, we want to see our global community. So if you're in Sao Paulo, Singapore, Seattle, Stockholm, let us know. And speaking of real time connections, I have to say that after all of the whiteboarding sessions, Ali, that you and I've done about streaming architectures, it is surreal that we're actually doing this today.
Yes, and we're not alone today. We have the person who literally, I know, dreams in shards and partitions. Please welcome John Morkel, the General Manager of Amazon Serverless Streaming and Messaging, including Kinesis Data Streams.
Thanks for having me, Ali and Mandy. Although I should clarify that these days my dreams are autoscaling shards, and as a result, I'm getting much better sleep.
Ali and John share a really special bond, by the way. They both have twins. The episode title is called Solving Real-Time Sentiment Analysis from Data Chaos to Elastic Streaming. And that's incredibly fitting. And only those of you who have twins or self-operate streaming technologies will truly understand the chaos to order journey.
That's exactly right. Okay, since this is our first episode, let's go through a quick introduction. Mindy, you want to tell our viewers what's your role at AWS?
Yeah, well, my role as a vice president of technology at AWS is really to oversee the services that function for collaboration, streaming, and data messaging. So my days are usually a mix of strategic planning, working with our engineering and product leaders on roadmaps. And you know what? I dedicate a lot of time in my day to work with customers. I joined AWS having been a customer. And so it really matters to me to understand a customer's biggest pain points. Ali, why don't you go next?
Absolutely. Let me tell you a little bit about what I do day to day. So, as a data streaming architect, I spend most of my time working directly with customers who are building mission critical streaming applications. We're talking about financial service companies processing millions of transactions per second, gaming companies tracking players' behavior in real time, IoT platforms ingesting sensor data from millions of devices. A typical day for me starts with a call with the customer who's dealing with a throughput bottleneck issue, maybe. And I'm reviewing architecture design, maybe doing a deep dive session on partition key strategy, and often I'm prototyping solutions or running performance tests. You know the best part? If every customer use case and streaming challenge is unique. In short, I connect our customers and our field community to the service team. And you know what? Mindy is the person who asks really tough questions, like why can't this just work automatically? Which honestly drives a lot of innovation at AWS.
Well, I am guilty as charged for that because I believe that technology should solve problems, not create new ones. And that's the philosophy that's really helped shape how my teams and I think about our data streaming services. We're constantly asking, how do we make something simpler? How do we actually remove any operational burden or friction? And how do we make streaming accessible to developers who aren't distributed systems experts? Now, for all of you joining us today, what are some of the most common streaming challenges that you encounter? Love to see you drop them in the comments. John, tell our audience what it means to be a general manager of a service like Kinesis Data Streams. What's your day-to-day look like?
Yeah, so I'm responsible for the overall vision, strategy, and execution for all of our serverless streaming and messaging services, such as Kinesis data streams. And that means that I'm working with my engineering teams on the features that they're building, as well as my product teams with how we position and price the services. And also critically, I'm spending a lot of time talking and listening to customers to find out what they need. Some of my best days really are when I'm in a customer meeting, hearing about their use cases, what challenges they're having, and maybe frustrations with some of the services that they've been using, and how we can fix those issues for them.
And those frustrations turn into real features, right?
Yeah, so the feature that we're talking about today, which is on-demand mode with warm throughput, this came directly from a bunch of custom conversations that we had, where we heard this same pain point over and over, which was, I love Kinesis, but I hate capacity planning. So that's something that we took to heart, and we built a new feature based off of that feedback.
And that's really, John, the kind of customer obsessed innovation that we want to showcase on this show. And we're not just talking about features in a vacuum, we're going to show you how real customer problems lead to solutions.
So before we dive deeper, let's talk about what this show is. Mindy, you want to take this?
Absolutely. So, data streaming now is our attempt to demystify real time data processing. Every episode, we're going to bring in experts. Today, it's John. We're going to do some live demonstrations and we're going to tackle real world streaming challenges. But this is not just another technology talk show where we throw some buzzwords around and call it a day.
Right. We want to show you the good, the bad, and the ugly, the architectures that work and those that they don't. And most importantly, why.
And each episode is going to follow a similar format. We're going to take a real customer problem. We're going to find something that we've actually seen in the field, and we're going to architect a solution live during the show. We're going to show you all the code, all of the configurations, the CloudWatch metrics, and we're even going to show you the mistakes.
Yeah, especially the mistakes. Because let's be honest, nobody gets to streaming right in the first try.
I'm sure our viewers are going to enjoy this honesty.
So, Ali, you and I were thinking about all of the streaming projects that we've seen succeed and all of the ones that we've seen struggle. And the successful ones always have someone who really understands the fundamentals, partitioning strategies, back pressure handling, exactly once semantics. And the struggling ones were just throwing technology at problems without understanding the underlying principles.
So we thought, why not create a show? We don't just talk about the streaming, but show it. Live demos, real architectures, actual gotchas. We'll bring in people like John who build these services, the people who use them in production, and we will have honest conversations about what works and what doesn't.
Yeah, and somehow you managed to convince me to be your first guinea pig. I mean, yeah.
We prefer a streaming pioneer volunteer, John. But seriously, you were our first choice because Kinesis Data Stream, where many customers start their streaming journey.
It's where I started my own data streaming journey, by the way. And John, it's because you've been listening to customer feedback and evolving the service in some really interesting ways. That's the kind of story that we want to tell on this show, how customer problems drive innovation.
Well, I'm super glad to be here, and I know that Ali actually has a demo planned a little later, which I'm a little nervous about, but
I should be nervous, but don't worry. We tested everything mostly.
Oh, Ali, we've tested everything thoroughly. And that's actually a good point, though, for our audience, because in streaming, you do need to test for failure scenarios. What happens when your producers go down? What happens during a traffic spike? What happens when your consumers can't keep up?
And we'll show you all of that today. No smoke and mirrors, no perfectly curated demos, real systems, real metrics, and real challenges.
well, this is either going to go well and be very educational, or be very entertaining when everything falls apart.
Well, hopefully both. And that's what data streaming now is all about, learning from real world scenarios, whether they go perfectly or not. All right, let's get foundational, Ali. Batch versus streaming. Give us the 60-second version.
Okay, so imagine you're tracking social media sentiment about your brand. With batch processing, you collect expos, let's say from social media platform all day, and then the midnight you process them and find out that yesterday people were all so not happy.
That's way too late to respond.
Exactly. With streaming, you're processing those posts as they arrive. Angry post at 2 p.m., you will find out 5 seconds later. And here's the thing, it's not just about the speed, it's about the entire mindset shift from asking what happened to what's happening right now.
Well, let's dig into that a little bit more. John, when you talk to customers about streaming, what are the use cases that really resonate with them?
Yeah, I think fraud detection is one of the critical ones. So, catching a fraudulent transaction before it's actually completed. Um, Either that or operational monitoring for more immediate failure detection. And also, with, say, social media, some real-time personalization based on current user interactions.
Exactly. And with AI models consuming massive amount of data, batch processing simply can't keep up with the millions of events per second.
But let's be real with our audience. Streaming is not always the answer, right? When should you stick with batch?
Good question. If you're doing end of the month financial reports, batch is fine. If you're running analytics that don't need sub-minute latency, batch is fine. Simpler and cheaper. The rule of thumb that I often give customers is that if the business value of knowing something 5 seconds ago versus 5 hours ago is significant, you need streaming.
Yeah, and there's a spectrum, right? So it's not just binary. It's not one or the other. You have hybrid architectures as well, where you use streaming for your hot data that you need real-time decisions on, and then you can also use batch for historical analysis or more complex analytics that will take a bit longer to run.
Speaking of complexity, Ali, let's talk about what makes streaming architecturally different. What are the key concepts that people need to understand?
Absolutely. Let me share my screen, and I have a few slides to talk about some of the fundamentals. So the fundamental shift is moving from data at rest to data in motion. In batch systems, you store data first, then process it. In streaming, data is constantly flowing through your system. You need to think about things like event ordering, handling late arrival data, and maintaining state across millions of events.
Yeah, this is where the infrastructure can actually get quite interesting, where you need systems that can actually handle this continuous data flow and also provide the durability that you need so that you don't lose any of these events as they come in. And then also scale up and down elastically as your traffic patterns change.
Exactly. And one critical concept, event time versus processing time. Streaming system need to handle when events are received at the different times than when they were actually generated.
And this is why streaming has a reputation for being so hard, right? You're dealing with distributed systems, temporal logic, state management, and unpredictable traffic patterns all at once. Ali, many viewers, and by the way, thank you to everyone who said hello to us from literally all around the globe. But many of our viewers are facing the exact same common challenge. They have batch pipelines that work, but they need to move to streaming. What's the key advice we have for them?
Right. So this would be my advice. Migration isn't all or nothing. Start by assessing which pipeline actually need real-time processing. Often it's only 30% of use cases. Things like fraud detection need streaming, but monthly reports, batch is fine. Pick your highest value, lowest complexity use case first.
Tell us about the technical shift, Ali.
Yeah, absolutely. So in batch, you process the complete data set. In streaming, you maintain state across continuous events, like sliding windows that update the data as it flows through. It's a fundamental mindset change.
And what about the operational differences?
Yeah, my advice on that would be that to run the both pipelines in parallel during the migration. Compare the results before deprecating the batch. And remember, with AWS streaming services like Kinesis Streams, especially with on-demand mode, you're paying for actual usage, not the peak capacity at 24/7, which changes the cost equation significantly.
Yeah, exactly. And at AWS, our mental model is that we want our customers to be able to focus on the business logic and not have to worry about the infrastructure management.
And that brings us to the real challenges. Ali, I know that you've seen customers struggle. So tell us, what are the real challenges they face?
Yeah, first is the unpredictable traffic spikes. When a viral post causes 10 times traffic, your infrastructure needs to handle that gracefully without dropping data. You can pause to scale up.
Yeah, and it's not just the peak traffic. You also need to be able to scale down during the troughs, and this is where decoupling comes in.
Exactly. Producers and consumers need to operate independently. If you're tightly coupled, updating your sentiment analysis model means coordinating changes across multiple systems, not resilient.
And that's where specialized storage systems like Kinesis data streams really come in.
Right. They buffer data between producers and consumers, allowing independent scaling. Plus, replay capability. If your consumer has a bug, you can rewind and reprocess.
I think you're going to tell us that this is where things start to get a bit tricky.
Here comes the plot twist.
Okay, so operating these distributed systems that are stateful is pretty hard. These capacity planning problems keep our customers up at night. And you have to think about things like how much throughput do you need today, next week, or maybe in 6 months when your application is taking off and your user base doubles.
And the cost model. Traditional streaming systems makes you pay for peak capacity 24/7, even if you only need it for 2 hours a day. Massive spikes during a business hours, quiet nights and weekends, yet you're paying for peak all around the clock.
So you're either over provisioned and wasting money, or you're under provisioned and you're dropping data. It's a true Goldilocks problem.
Yeah, and this is the feedback that we keep hearing from our customers, which is, I'm spending more time managing my capacity than actually improving my application and building features. So we asked ourselves, what if customers didn't have to think about the capacity planning or the scaling at all? And what if their infrastructure just adapted automatically to whatever their traffic pattern was?
John, you've been with Kinesis Streams for a while. How has it evolved based on customer feedback?
Well, it's been quite the journey. When we launched Kinesis Data Streams, customers really loved the managed service aspect. It was a serverless offering with no service to manage. There was automatic replication, so you got durability. But they still had to do some amount of capacity planning for their shards. And in Kinesis Data Streams, we've got the concept, which is the unit of capacity called a shard. And you can think of this as, a lane on your highway. In order to increase the volume, you need to add lanes to allow more traffic.
And the classic, how many shards do I need question is one that's quite familiar to us.
Exactly. Well, so for customers who understand distributed systems, this model makes sense. You're partitioning your data stream across multiple shards, and each shard maintains ordering within its partition.
Yeah, right. And so, customers will ask something like, I have a big marketing launch next week. So how many shards do I need? 50, 500? And then what do I do after that event is over and the traffic has dropped off? So, once you're provisioning some shards, you're paying for them whether they're being used or not.
Yeah, you would over provision just to be safe.
That's right. And so we've guided our customers to build auto-scaling solutions, which sets policies up that automatically will add or remove shards based on application metrics such as the incoming data rate or the maximum iterator age.
But that still requires management, right?
Yeah, so customers still had to set points for their scaling. They had to monitor these metrics. They also had to tune the policies. over time. And the other thing is the scaling when you're managing it this way isn't instantaneous. It takes some time to add a shard, and it also takes some time to split shards up. So when this process is taking place, while the scaling is going on, you might actually experience some rate limiting of your incoming data.
I've seen customers get this wrong all the time. Some thresholds set the thresholds too conservatively and still experience throttling. Others set them too aggressively and ended up with unnecessary scaling operations.
And then came on-demand mode.
Yes, so we asked ourselves, what if customers didn't have to think about capacity at all? And so with on-demand mode, Kinesis automatically manages this capacity for you. So it's continuously monitoring your traffic patterns and then adjusting the number of shards accordingly, which means you don't have to make these scaling decisions on an ongoing basis.
So instead of asking how many shards do I need, they just ask, what's my data volume? That's genuinely simpler.
Yeah, and the cost model is a lot more predictable. You're just paying for your actual usage. You don't have to pay for provision capacity. So for a workload with variable traffic patterns, this can be a lot more cost effective.
But Ali, I know you're going to bring up some spiky workloads here.
Oh, absolutely. Here's the real world scenario. You might have a stream that's quiet overnight. Then at 9 a.m., you get a massive spike, going from 1 megabyte per second to 100 megabyte per second in minutes.
Yeah, this is the common issue that many services have when the start of business day occurs and all your customers start using your system all at once.
Exactly. With on-demand mode, even though it's scaling automatically, there's still a lag. Kinesis needs to detect the spike and split shards during the ramp-up period. You might experience throttling. And by the time you reach capacity, your spike is over.
So you're getting throttled during your most critical time.
Potentially. Well, our specialists came up with this workaround. They would switch from on-demand to provision mode before the spike, and manually provisioning enough shards, then switch back after. Creative but a little bit painful.
Yeah, we definitely saw quite a few customers doing this, and it works, but it's kind of against the whole point of on-demand mode. So you're back to doing capacity planning and this manual operational overhead, and this is the complexity that we're really trying to eliminate for our customers.
Yeah, and if you forget to switch back, you're paying for provision capacity unnecessarily.
So customers were essentially hacking around our on-demand mode to handle spiky workloads.
Yeah, that's right. And so this feedback told us something, which was that on-demand mode is working well, but we need to solve for these unpredictable traffic spikes. And customers shouldn't have to choose between the simplicity of on-demand or the responsiveness that they need for these business-critical workloads that happen to have spiky traffic.
Which brings us to the innovation you're about to tell us about, right?
Right. So I'm super excited about on-demand advantage mode with warm throughput. And this is where things can get really interesting.
Yeah, John, this sounds amazing, but I'm a skeptical architect. And what are the gotchas? How does this actually work? Because warm pooling a distributed stateful system, I know it's not trivial.
Well, you're not alone in being skeptical, and I do love that you're asking me this question, because with on-demand advantage, we're constantly monitoring your traffic patterns and automatically splitting or merging the shards as needed. But the key innovation is we don't wait for you to hit the limits before we scale.
So predictive scaling?
Exactly. But even with predictive scaling, splitting of the shards takes some time. So there's a physical limit to how fast we can actually provision new capacity and split the shards. Now, with warm throughput, you can specify a baseline capacity that's always ready. You can think of it as keeping some shards ready for you that are warmed up and able to handle any sudden traffic spikes as they come in. And just to maybe give a concrete example here, so you know that every morning at 9 a.m. your traffic, say, goes from about 10 megabytes per second to 100 megabytes per second as your customers start using the service. Now, with standard on demand, we would detect that spike and we would start scaling, but there would be a few minutes of lag where there's potentially some throttling that would take place.
And that few minutes is exactly when your business critical data is flowing.
That's right. So with warm throughput, though, you can say, I want to keep 50 megabytes per second of capacity warm at all times. Now, when that 9 a.m. spike hits, you've already got 50 megabytes per second ready to go. And then beyond that, the on-demand mode will still scale you all the way up to 100 megabytes per second if needed. But you're not starting from the baseline. You're starting from that new warm throughput level.
So it's kind of cool. You get the elasticity of on-demand, but the responsiveness of provision capacity.
Yeah, that's it. And here's the really neat part is you're not actually paying for this warm capacity. During those quiet overnight hours, when you're only using 5 megabytes per second, say, you're only paying for the 5 megabytes per second that you're using. The warm throughput is just a reservation, and it's not a minimum per stream charge.
Can you tell us a little bit more, though, about the cost model and how should a customer think about pricing with warm throughput?
Yeah, that's an interesting question. So with on-demand, you're only paying for what you're actually ingesting and reading out, which is measured in gigabytes per hour. And then with on-demand advantage, there's a slightly different pricing structure. There's no longer a fixed per stream charge, and the actual throughput that you're metered for is priced at a slightly lower rate, and then the only requirement here for this pricing model is that your overall account commits to using streams in aggregate of up to 25 megabytes per second of ingest and 25 megabytes per second of retrieval. And the customers that meet that threshold, they see between 40 and 60% cost reduction compared to the same workloads on provision mode. But they also get this better handling of spikes and better scaling than the on-demand mode.
Okay, I'm impressed. But I think our viewers want to see this in action, because theory is great, but many engineers like to see the matrix, see the behavior under the load, and how it actually performs.
Yeah, this is the part I was a bit nervous about, but let's get into the demo, Ali.
All right, folks, demo time. So here's our use case. We're building a real-time sentiment analysis pipeline for social media. We are ingesting posts, analyzing sentiment, and detecting when sentiment suddenly shifts. I see in a comment a great question, and I'm going to answer it right now. What makes this demo really interesting is because it simulates a real world traffic pattern with distinct phases that mirrors actually what happens in production. We start with a baseline of around, let's say, 1,000 posts per second, your typical steady state traffic. Then suddenly a celebrity makes an announcement about the product on social media. Boom, traffic spikes to 5,000 posts per second as their followers start engaging. But it doesn't mean that it stops there. As news outlets and other influencers pick up on that story, we see a second wave. Traffic surges to 10,000 posts per second as everybody piles on. Eventually, the buzz dies down, though, and we return to our average baseline. So the critical thing about this workload is that the unpredictability. Unlike scenarios where you can pre-scale like a planned product launch or a scheduled marketing campaign, these organic viral moments are impossible to anticipate. This is exactly the kind of workload that traditional capacity planning struggles with. And it's where on-demand advantage mode with warm throughput really shines. But before we see it in action, let me show you how easy it is to get started with this demo. Everything we're showing you today is open source and available on GitHub, and we'll share the details in the show notes after the live stream is over. But I'm going to switch over to my browser and show you the project. And if you want to get this set up locally, I'm using Kiro as my development environment. For those who are not familiar with Kiro, it's an agentic enabled development environment, but you can run it anywhere, your local machine, wherever you're comfortable. The key dependencies are AWS CDK, needs to be installed, Python 3.12 or later, and the AWS SDK, and obviously the latest version of AWS CLI. All of this is documented in this README file, but honestly, if you have the AWS CLI configured and the CDK installed, you're 90% of the way there. But here's the part that I love about this project, that everything is true infrastructure as code. So the CDK script creates the entire stack for you. The Kinesis data stream, all the IAM roles and all the dependencies, even your producer and AWS Lambda functions. It containerizes your producer and also deploys it on Amazon Elastic Container Service or Amazon ECS. And then everything that we are going to run today, you can deploy it with a CDK command, CDK deploy, and you're up and running. And also, what makes this demo interesting is I've provisioned this stack in 2 separate AWS accounts. Account 1 runs Kinesis data stream with standard mode. Standard on-demand mode, I'm sorry. And account 2 uses on-demand advantage with the 100 megabyte per second warm throughput. This lets us compare their behavior side by side under identical spiky workload, infrastructure as code as its finest.
So the infrastructure's ready. Now what?
All right, now I'm going to kick things off. Everything is controlled through this demo manager shell script. Let me show it to you. So here, what I'm going to do in on-demand standard mode, I'm just going to go to the scripts folder and then run the demo manager with the start command. And this is gonna start our demo. This will start our event producer that simulates the social media post and also invokes the step function that controls all phases of the demo that we talked about. And let me repeat that in another environment. For on-demand mode, you can pass in the warm throughput parameter, and then you just pass in the number, and it will check if the Kinesis data stream is created with this configuration, and then it will check other dependencies, and it will run the demo. So let's start the demo, and we'll circle back in a few minutes to check on the phase 1.
Ali, we've got some great questions that are happening in the chat, like folks telling us they love using the CDK for infrastructure provisioning on AWS. We'd love to hear comments like that. Can you tell us, though, a little bit more about the architecture?
Absolutely. So let's talk about the architecture. So our producer generates posts, maybe like just tried the new product, absolutely love it. And then the producer writes this post to Kinesis data stream with a partition key. In this demo, we are using a random partition key to ensure all posts are distributed evenly. Kinesis data stream stores the events durably across multiple availability zones, and this happens in milliseconds. AWS Lambda consumes and polls Kinesis data stream and gets a batch of records up to 500 posts. AWS Lambda calls Amazon Bedrock for Nova Light model with that batch, and then also comes along with a prompt saying classify the sentiment of these posts as positive, negative, or neutral, and then return the results in the same order. Nova Light returns the sentiment scores, and then AWS Lambda writes the results to Amazon CloudWatch, is the serverless service we are using today for visualizing. And also Amazon Data Firehose that syncs the data to Amazon S3 table, which we are using for our analytics. The total latency from the post creation to the dashboard update, typically under a second, even under a heavy load.
See, that's a great example because one of our folks watching is asking for a real world sentiment example for the sentiment analysis. And all of this is happening right now in real time, right?
Exactly. From the moment a simulated post is created to when we have a sentiment score, we're talking about sub-seconds. This is the power of streaming. Let's check in with our demo again and see the call watch matrix as see that the messages are flowing through. So I'm going here and I'm going to refresh my screen. So we can see that a Kinesis data stream on demand is created for us. And let's go in our dashboard and let's see how is it doing. So as you can see in real time, we are seeing that the posts are coming through and we are currently at our baseline. So if you look at the number of messages that they're coming through, they should be around 500 or maybe 1,000 per second as our TPS. So uh, as the messages are coming through, we see a little bit of updates coming through. So we'll check in back with this demo a little bit later. So as I mentioned, Kinesis Data Stream on Demand is handling our baseline without any throttling right now, as you can see. And then let's revisit this in a few minutes after the first spike is going to hit in a few minutes. And John, why don't you tell our audience about some of our public reference customers, those ones who are using Kinesis and truly massive scale?
Yeah, I'd love to. So we've got some really great customer stories of those that are having good success using Kinesis data streams. And one of the bigger customers that we have is actually Amazon.com. So during Prime Day, Amazon.com processed a staggering 807 million transactions per second through Kinesis. And on a given day, over 3.4 million streams are pushing about 70 petabytes of data into the service, into Kinesis data streams. And our largest streams handle over 10 gigabytes a second. And so this isn't just theoretical. This is like real workloads that we have running right now that are powering many mission critical applications, such as all the applications on Amazon.com that were used to deliver customers their packages during Prime Day.
And these are just an example of some customers who we've worked with to understand their needs. And we work backwards from their requirement to enable innovations like on-demand advantage mode. So we make the infrastructure invisible so that developers can focus on solving real business problems.
Yeah, that's right, Mindy. It didn't happen in a vacuum. This came from working directly with our customers very closely and understanding what the pain points were that they were trying to solve, and then building some solutions that address these real world challenges that they had. And this is the origin story of Kinesis on-demand advantage.
John, before we move on, I want to dive deeper into something that I think will really help our audience understand, which is what's happening under the hood. How does Kinesis data streams actually scale? Can you walk us through the mechanics?
Yeah, I'd be happy to. So, like I said originally, the unit of capacity for a Kinesis data stream is a shard. And a shard gives you a megabyte per second of write capacity and 2 megabytes per second of read. And a property of a shard is that it maintains the sequence of records that are written to it in order. And the interesting part here is that when your stream needs some more capacity, we don't just arbitrarily add some new shards to the stream. We actually split the shards that you have. Because imagine you have a stream here with, say, 4 shards, and each shard is handling a range of your partition key hash value space. So just a thing to add is when you actually write a record, you are specifying this hash key, well, this key that is used for actually distributing the data across your stream. So in a situation where you have 4 shards, the first shard is handling the first 25% of that hash space, second shard the next 25%, shard 3 and 4, etc., are each handling 25% of the overall partition key space. Now, if we add a 5th shard arbitrarily, the question is what data actually would end up being written to that shard. So we'd have to actually remap some of these partition keys to be able to distribute the load into this new partition, this new shard. And so the data that was previously going to say shard 1 might actually now go to shard 5, which breaks any of the ordering guarantees that you might have had, that you might have been relying on in your application. And this can also create a lot of chaos at the consumer level when you're trying to track state of the events as they're coming in.
So splitting maintains the hash space integrity.
Yes, that's right. So when you split a shard, you take one shard and you divide its hash range into two children, and or twins, you may think. So the original shard is closed, and then no more new data can be written to it. But consumers can continue to read any data that they haven't yet consumed until they've read up until the end of that shard. And then the producers will keep writing, but the producers will start writing data that's now split across into the newer shard, the new children shards. And all of this is going on where the infrastructure just allocates new capacity for these shards, and there's no interruption in your ability to be able to write data in or read.
Now, what about the advantages of this approach versus other streaming systems?
Yeah, so some streaming systems actually require you to pre-partition your data and don't allow for any kind of dynamic repartitioning. So if you start with 10 partitions, that's it, you're stuck with 10 partitions. Unless you go and create a new topic and have to do a data migration. With Kinesis data streams, we can split these shards dynamically, which is a key innovation of Kinesis data streams. And that means that your stream can seamlessly grow as your traffic scales.
This is fascinating. So the key advantages of shard splitting approach are maintaining ordering guarantees, targeted scaling where you need it, seamless consumer rebalancing, and the ability to scale both up and down dynamically.
Yeah, that's right. And with under-mine advantage mode, we've optimized this even further. So we're splitting the shards when you set the warm throughput, and we use some predictive algorithms that look at your previous traffic to suggest what amount of warm throughput you would need.
And that's what eliminates the throttling. I guess we are going to see in our demo, right? I think our audience has a much better understanding of what's happening under the hood right now. This isn't magic. It's just a clever running distributed system engineering, right? Let me switch back to the CloudWatch metric and dashboard so we can check in with our sentiment analysis demo and see what is happening. All right, so let's refresh this CloudWatch dashboard. Oh, we are seeing some throttled records, 2.25 million records of them. So they're getting throttled here as a result of the spike is happening. So let's see how our metrics are looking. So I'm just gonna zoom in a little bit here. Let's refresh this. Okay, so apparently we have gone from, okay, so it's refreshing. Let me go back to 1 hour. Some delay here. Looks like we have been running on less than 1,000, like 500 transaction per second, and we have been doing fine. But then as soon as it reaches over 5,000, about 10,000, we are seeing that throttling starts there. And then especially this is interesting. So it basically scales up, and it's now the throttling, as soon as the throttling wants to go down, again, another spike hits. And then we are seeing that the throttling is happening again. So let's see how this behavior actually looks like when we run the same test on the on-demand advantage mode. So I'm going to refresh this one. Oh, no throttle here. Look at that. So it handles perfectly when it goes from a couple thousand events per second to all the way 10,000 per second. So we see zero throttle, and all of the 3 million, almost 3 million events are being processed correctly. And this is the part. This is the real-time dashboard part that I'm really excited about. Let me show you that. So we in real time we are tracking our sentiment analysis, and we can see how the sentiment is shifting. See this sentiment score? It's moving as soon as the spike is happening and more posts are coming through. But then also we can maintain the state across all these events, showing all the average of 0.7 number across all these events. As you can see, as the results are coming through, this dashboard also is updating in real time. This is great. All right. So with that, I would like to also show you a little bit of how the processing is handling with AWS Lambda. As I mentioned, our consumer model is using an AWS Lambda, and this AWS Lambda function is connected to our Kinesis data stream with an open source mapping. And if I open the open event source mapping, you can see that it's batching the records with 500 as a batch size and 5-second batch window. Um, the reason we are batching records here, I want to emphasize this, is that the batching is really going to help us with the optimization, because AWS Lambda collects up to 500 posts from Kinesis before invoking our function. And this is crucial for effectiveness and efficiency when calling something like large language models. Instead of making 500 individual calls to Amazon Bedrock, we make one call with 500 posts batched together.
And that's going to dramatically reduce both the latency and the cost, right?
Exactly. There is always a balance here. Notice that we have a batch window of 5 seconds as well. This means that the AWS Lambda will wait up to 5 seconds to collect records. But if we get 500 records before that, that invokes immediately. So during the high traffic, we are processing a full batches of 500. During the low traffic, we are not waiting forever, and we process whatever we have after 5 seconds.
This is an interesting example of the spectrum between batching and streaming. And, in this case, we were streaming with some very small micro batches, and it's a great way to be able to handle these variable traffic patterns.
Absolutely. And here's the CloudWatch metric for our AWS Lambda function. And look at the duration our function is constantly completing, which is under 2 seconds. And even during the peak load, that's the power of batching. If we were processing one post at a time, we would be looking at much higher latencies.
Well, what about the errors, Ali? Are we seeing any failures?
Well, let's find out. Great question. Let's see. So from this metric, I'm not seeing any error, but let's go and open the logs and see what we are finding in the logs. All right. So I'm going to just open one of the latest logs and look at all the log entries. And you can see exactly what's happening in real time. All right. So here's that you can see our batch is picked up about batch of 20 posts are being sampled and sent to Amazon Bedrock. We are seeing in this case that our batch size is lower than 500. So you can see that the total batch size here was 132. And the reason for that is when the Kinesis data stream shard count increases, then the Lambda invocation also concurrently increases with that. So then the batching basically becomes a little bit, less in size. But as far as I can see, I don't see any errors. So everything is being handled gracefully.
Excellent. Excellent. And you can watch the dashboard with sub-second latency, right, from the time that the post is created. It kind of goes with this question we just got, which is, can Kinesis data streams handle event streaming? So for threat detection and sub-millisecond.
Exactly. And look at this time series graph. It shows the sentiment over time, and you can see when the viral moment hit here, for example, around this time. And then the beauty of it is from the post creation to this dashboard, we're talking about like less than a second, maybe 500 millisecond. And this includes writing to the Kinesis data stream, AWS Lambda processing, calling Amazon Bedrock, updating CloudWatch metrics.
I mean, that's really what modern streaming architecture should look like, right? Simple, scalable, focused on the business value.
Exactly. Couldn't have said it better myself. And remember, all of this code for our audience is available in our GitHub repository, and I can you can deploy this exact same architecture in your own AWS account. And just I would like to caution you about the cost and make sure you understand you run it at the lowest scale and you understand the cost implication before you run it in your account. But I would like you to try the demo and get a hands-on experience with Kinesis Data Stream yourself. And if you also are wondering how you can get access to the URLs, I have left a few resources for you here. So you can take a picture of these QR codes, and one of them, at least one of them, should take you to the demo. The rest are some other useful resources that we'll leave for you.
Ali, it was incredible. I'm a little shocked that the demo went off without like really major errors. We all know in software engineering, never ever attempt a live demo. But let's actually take a step back and recap what we've learned today.
Sure. So first we covered a lot of ground. So let me break this down into the key takeaways that I hope everyone watching and can apply to their streaming architectures. First, we talked about why streaming is best for real-time insight. And this isn't just about speed, right? It's about fundamentally changing how your business operates. When you can detect a problem, an opportunity, or trend, it's happening rather than hours or days later. You can actually do something about it. That's not just a technical improvement, that's a business transformation.
And it's not just about being faster, it's about being more responsive to your customers, to your market, and to your operations.
Exactly. Second takeaway, the challenge of operating distributed streaming systems. And I want to be really honest with our audience here. Streaming has more design considerations than batch. You're dealing with distributed state, you're handling unpredictable traffic patterns, you're managing ordering guarantees across partitions. These aren't trivial problems, but understanding these challenges is the first step to solving them.
Yeah, this is something that my team spends a lot of time working on and thinking about, and this is where the real power of a managed service comes in, right? So you don't have to solve all of these problems yourself.
Right. Which brings us to our third point, how Kinesis Data Stream on Demand advantage or standard eliminates the capacity planning. This is huge. Imagine you're a retail customer paying for Black Friday capacity year round. With on-demand mode, you're paying for what they actually use. During the quiet periods, costs are low. During busy periods, capacity scales automatically. No more spreadsheets trying to predict traffic 6 months from now or anything like that.
And the cost savings can really be significant. Our customers have been telling us that they're saving like 40 to 60% for many of their workloads that are compared with over provision capacity.
Absolutely. And fourth, this is the innovation that really excites me. The magic of warm throughput for handling spikes. This solves that painful problem we talked about where customers were switching between on-demand and provision mode. Now you get the best of both worlds.
And finally,
all right, building efficient AI pipelines with summarization strategies. This is something I see customers get wrong all the time. They build these beautiful streaming pipelines, then they call their LLM for every single event and wonder why they're hitting the rate limits and backing up costs. Summarization is your friend. We showed how grouping 500 posts together for sentiment analysis dramatically improves throughput and reduces cost today. And you can apply the same techniques in your use case as well.
And it applies to actually any AI workload. So whether you're doing classification, summarization, entity extraction, whatever, just think about summarizing raw events into an actionable insight within an input prompt for your agentic AI.
Yeah, hopefully the viewers are able to see how elastic streaming doesn't have to be complicated or expensive. The technology here has actually evolved to the point where you can focus on what's important to your business, and you don't have to think about managing the infrastructure.
And that's the key message I want people to take away. Streaming is more accessible now. You don't need a PhD in distributed systems. You don't need a team of infrastructure engineers. With the right tools and patterns, you can build production-grade streaming applications.
Speaking of which, what's next for data streaming now?
All right. Episode 2 is going to be amazing. We are diving deep into one of the popular use cases. Anybody can guess what? Anomaly detection patterns. And we are bringing in another guest. We are going to show you how to detect anomalies across multiple dimensions in real time. Things like detecting fraud patterns, identifying system failures before they cascade, spotting unusual user behaviors, you name it.
These are near and dear to my heart, especially coming out of financial services. We're going to show you how to build sophisticated streaming analytics that can detect anomalies in real time across multiple data dimensions.
And here's a teaser. We are going to show you how to combine another very popular streaming storage. Guess what? Amazon Managed Streaming for Apache Kafka or Amazon MSK with Amazon Managed Service for Apache Flink to build and operationalize it.
So make sure you subscribe, hit the notification bell, join us next time. We're going to go even deeper into the technical details, and trust me, you don't want to miss out on this.
Yeah. And if you have questions about today's episode, or there are specific streaming topics you want us to cover in future episodes, drop them in the comments. We read every single one. This we try, and your feedback directly shapes what we cover. Thanks for joining us throughout the show, and thank you to John for taking us under the hood of Kinesis Data Streams as our first guest.
Yeah,
Thank you for
Thank
watching.
you for watching Data Streaming Now. Woo!
Woo!